Have you ever built something with building blocks? You take different pieces, squares, rectangles, triangles, and put them together to create something amazing, like a castle or a spaceship. Well, in the world of computers, service-oriented architecture, or SOA, is a lot like that. It's a way of designing software where big, complicated programs are broken down into smaller, independent parts called services. Each service does one specific job, and it does that job really well. Think of one service handling payments, another looking up customer info, and a third checking if a product is in stock. They're all separate but designed to work together. This idea isn't brand new, it's been evolving for a long time. In the early days of computing, programmers realized it was smarter to build software in modules, reusable chunks of code that could be plugged into different projects. This led to something called remote procedure calls, or RPCs, which was a neat way for one computer to ask another computer to run a piece of code for it. It was kind of like calling a friend to borrow their calculator instead of buying one yourself. This was the seed from which the great SOA tree would eventually grow, establishing the basic principle of computers sharing their own special capabilities over a network, which is really cool. Then, the internet came along, and everything changed. With the rise of the World Wide Web, new technologies popped up that made sharing these services much easier. Things like XML, which stands for Extensible Markup Language, provided a common language for data, while protocols like SOAP, Simple Object Access Protocol, and later REST, Representational State Transfer, created rules for how these services would talk to each other. Suddenly, it didn't matter if one service was written in Java and another in Python. As long as they could speak the web's language, they could communicate perfectly. This made SOA super popular with businesses. Today, SOA is more important than ever, even though it might look a little different. It's the driving force behind many things we use every single day. When you stream a movie, book a ride, or order food online, you're likely using a system built on SOA principles. Modern approaches like cloud computing and microservices, which are like super tiny, super focused services, are direct descendants of this idea. Businesses love it because it gives them incredible flexibility. They can update one small service without having to rebuild their entire system, allowing them to adapt quickly, fix problems faster, and keep on innovating. It's all about building powerful, adaptable systems from simple, smart pieces. Robots. That word might make you think of shiny, human-like metal robots from science fiction movies. But the idea of making automated machines is actually really old. Hundreds of years ago, inventors and clockmakers built amazing automatons, mechanical figures that could write a sentence, play a musical instrument, or even mimic a bird's song. These were engineering marvels, using complex systems of gears, cams, and springs to do their tasks. They didn't think, of course, but they were the first steps on a long journey toward making machines that could do human-like actions. They showed us that it was possible to make something lifeless move and do something useful, all on its own. The big leap forward came during the 20th century, especially with the start of the industrial age and electronics. The first real industrial robot, called Unimate, started working on a General Motors assembly line in 1961. Its job was to lift and stack hot metal parts, a dangerous and repetitive task for humans. This was a game changer. Unimate wasn't smart. It was just a strong, programmable arm that followed a set of pre-recorded instructions over and over. But it kicked off a revolution in manufacturing, proving that robots could handle dirty, dull, and dangerous jobs with incredible precision and endurance, working 24 hours a day without getting tired. But just following instructions wasn't enough. We wanted robots that could think. The next big development was combining robots with artificial intelligence, or AI. Researchers started giving robots sensors like cameras and touch detectors to sense the world around them. They developed software that let robots process that information, learn from it, and make decisions. Instead of just repeating a movement, an AI-powered robot could now do things like identify an object, figure out the best way to pick it up, and navigate around obstacles in its path. This was the moment robots started to change from being simple machines to truly smart partners. Now think about the world we live in today. In this year of 2025, robots are everywhere. And they come in all shapes and sizes. In warehouses, short, zippy robots scoot around carrying shelves to human workers, making online shopping faster than ever. In hospitals, surgical robots help doctors perform delicate operations with superhuman precision. And in our homes, robot vacuums clean our floors while we're out. These modern robots are connected to the internet, equipped with advanced AI, and designed to work with humans. They're no longer just tools. They've become a big part of our daily lives, making things safer, easier, and more efficient. So we have this cool way of building software using shareable services, SOA, and we have these amazing physical machines that can interact with the world, robots. What happens when you bring them together? You get something truly extraordinary. Imagine a robot on a factory floor. In the old days, all its brains, every instruction for every possible task, had to be stored inside the robot itself. This made the robot expensive, heavy, and super hard to update. If you wanted to teach it a new trick, you had to reprogram it directly, which took time and special skills. This is where SOA changes everything. By applying service-oriented principles to robots, we don't need to put all the smarts inside the robot. Instead, the robot can be a simpler machine designed for movement and action, while the heavy thinking happens elsewhere. The robot can use its network connection to ask a service for help. For example, if it sees something it doesn't recognize, it can send a picture to a powerful object recognition service running on a server miles away. This service, with its massive processing power, identifies the item and sends back simple instructions. That's a screwdriver. This powerful combination is the basic idea behind what we call cloud robotics. The cloud is just a term for a network of powerful servers that can store data and run complex software. In a cloud robotics system, the robot is the hands and eyes, while the cloud is the brain. This brain is made up of many different services, just like in SOA. There might be a service for navigation, another for speech recognition, and another for solving complex problems. The robot can access any of these services whenever it needs them, giving it almost unlimited intelligence without needing a supercomputer on its back. Think about how this works in a real-world scenario, like a smart warehouse. A fleet of robots works together to fulfill orders. Instead of each robot having its own map, they all connect to a central pathfinding service in the cloud. This service has a complete view of the entire warehouse. It knows where every robot is, where all the items are, and where any obstacles might be. It can then give each robot the most efficient path, preventing them from bumping into each other and ensuring the whole operation runs smoothly. This level of coordination would be almost impossible if each robot was working on its own. It's the power of shared services that makes it all work. Looking ahead, the partnership between service-oriented architecture and robotics isn't just a cool trick. It's the basic building block for the future of automation. As our cities, homes, and factories become smarter, they'll rely on huge networks of connected devices, from self-driving cars to delivery drones and medical helpers. None of these devices can work alone. They'll need to talk to each other, work together, and share information smoothly. For example, a self-driving car won't just rely on its own sensors. It will constantly call on services for real-time traffic data, weather updates, and road hazard warnings from other vehicles. This way of building things is key to making smart cities. Imagine a city where traffic lights, public transport, emergency services, and energy grids all talk to each other. A traffic management service could look at data from thousands of cars and sensors to make traffic flow better in real time, cutting down on jams and pollution. An emergency response service could automatically send ambulances around traffic and get the hospital ready for a patient's arrival. Every part of the city, the lights, the buses, the hospitals, acts as both a user and a provider of services, creating a living, breathing system that's much more efficient and responsive than just the sum of its parts. The same idea applies to the future of work and industry. Factories will become places with lots of robots working together, or cobots, that work side by side with people. These robots won't need to be reprogrammed for every new product. Instead, a factory manager can just put new software services on the cloud, and the whole group of robots will instantly learn a new set of skills. This makes manufacturing incredibly flexible, letting companies switch from making one product to another almost overnight. It's a future where physical machines are as flexible and updatable as the software on your phone. In the end, combining service-oriented architecture and robotics is all about creating smart, growing, and flexible systems. By breaking down complex smarts into easy-to-manage and shareable services, we can build advanced robot systems that learn and change. We can create smarter cities that serve their people better, and we can design more efficient industries that are kinder to our planet. It's a powerful idea that by linking simple, specialized services, we can build a future of automation that's more capable and cooperative than we ever thought possible. And that's a future worth building. Think about that.